Welcome to the first Substrate Sync of 2026. Got a actually pretty light agenda today, so we can just kind of kick it off. The first item on it was just I want to chat a little bit about consolidating protobuf and other artifact generation. Although this has already been discussed in the issue I've linked in the agenda, and which is kind of just mentioning it to people here in case you're not familiar, but in Rust and Python, there's been interest in separating out the generation of protobuf artifacts from the library. So instead of waiting for someone to like update the submodule and the libraries and generating the protos, what if when we release a version of the Substrate stack, we also package up the protobufs in its own as a library. So on a per language basis, we have like a protobuf library for Python, a protobuf library for Rust, and for Java, and so on and so forth. We've discussed the machinery for that, and we're starting to implement basically that work. And as part of this work, we've also realized that there's more than just protobufs to publish. There's like Antler grammars or generated Antler stuff in some cases. There's generated YAML bindings in some cases. So we're looking at kind of a more general purpose solution for that in a new repo we're calling Substrate packaging, where the idea is to decouple the release machinery from the Substrate spec releases. So you release a version of the spec, you bring in a version of the release machinery, and then you release all the artifacts you want based on that. This is a really high-level discussion of it. There's a lot more details in the issues, and yeah, if you start seeing PRs being thrown around to move code generation into a new repo and outside of the language libraries, that's what's happening. Guys, any questions on that?
My only concern is keeping track of what version we actually support. Just because a system has been built with a particular version of the Substrate spec doesn't mean it actually supports it.
I think that's also a problem now anyways, because even if you update the submodule, in some cases people do it just to get access to new extensions. We are starting to think about this a little bit internally. Actually, Ben's looking at some stuff around, can we generate like a feature matrix or something to be like, hey, here's what the libraries actually support in practice based on like actual tests that we run against them. But we'll talk a bit more about that once that's more public, I guess, and we get that open source, which we're also in the process of doing. I guess we're not making anything worse right now, David, as I will say. It's still decoupled. It just means that now if you want to update the protobufs, you don't have the submodule.
You're not making it physically worse, you're making it a little bit more effort to figure out what actually is supported. Because at least for like Substrate C++, I mean, it was not pushing the Substrate core version on purpose.
Version on purpose. Can you repeat that? Sorry.
And the Substrate text plan, it automatically builds based on the protos. It builds an actual visitor, and by rebuilding the visitor, you will have unsupported things, which means that the code will not work if you bring it up too fast.
Interesting.
So you'll actually have to go and fix a code in order for that to work.
Okay.
But I mean that's an exception, I guess.
Yeah. I think some of the other libraries they won't misbehave in the same way, but you'll definitely update the protobufs, and then you'll be like, well, the protobufs hand it for in Substrate Java, unless you add like poser support, you can't really support the feature. But this does solve a bunch of other problems. So in Python specifically, if you want to depend on the Substrate protobuf with a different version than the library does, you can't do that right now. There's also some other hacks in the way that the protobufs get generated in Python specifically that don't let it work in other parts of the ecosystem sometimes, so we're fixing that as well. There's a lot more specifics in the issue, and I think we've chatted a bit about this as well. So I'll defer to that for now, unless there's any other questions for the meeting right now. Cool. I think the next topic is you, Ben.
Yeah, so I wanted to discuss the parameter consistency setting. I opened up a PR to provide a default value for the parameter consistency setting which Victor then asked if I could provide some examples demonstrating, the different cases of consistent versus inconsistent, which then led me to want to find really good examples of functions that are worth including in the core extension set that actually make use of this consistent versus inconsistent behavior. And I couldn't find or think of one that is used in any existing databases. Of course, there's a lot of databases. I'm not going to claim that I did an exhaustive search, but one didn't immediately come to mind. So I'm curious if there is like either a good example that can help justify this particular feature, or B, if it might make sense to just remove it altogether. I did find one possibly good example, by the way, which is JSON build object from Postgres, which kind of takes in arbitrary types, but always outputs JSON, which I guess shows the value of inconsistent.
Equality is a consistent example, right?
Well, only if you support variadic equality.
Yeah. Mm.
So then is it worth adding variadic equality as a core function to the substrate spec?
Are you arguing that there's no purpose for consistent?
I am arguing that at the current state, we have no functions in the core extension set which use consistent or inconsistent behavior. And I think it would be good to either have some which actually show the difference between these two things, rather than just kind of like made up examples I was adding in the documentation, but actual core functions, or get rid of it is what I'm proposing.
I think part of this is we're missing the historical context to know why this got added and what it's for, and we're just trying to figure out what's the example that justifies the existence of this, that we communicate it both to ourselves and to other users. And if we can't think of one, it's even worth having.
Exactly.
Yeah, I mean, I think the I don't know what it's called, but the I believe that there are functions which are construction of structs where it's name. They need to be, it's equal number of arguments, but it can be some arbitrary number of arguments where it's name, value, name, value, name, value. I think that's an example of an inconsistent.
I mean, that's the JSON build object one is like that too.
And I think that, I mean, in terms of consistent, I feel like the question I'm trying to think about is that, like, in compilation, I feel like it's a common pattern to collect things like that are consistent together, right? Like, I'm adding 6 values, or things like that. I'm doing a Boolean or amongst several operands.
Sure.
I think it's, for instance, like when you construct the in list or multiple arguments, you naturally gather all the values and then either do narrowing, widening to make it a common type, and then deal with that like one single type for all of them. So yes, there are cases like this struct building or whatever. There are things that naturally expecting inconsistent thing, but there are more cases, I think, requiring the consistent behavior, let's say.
This was a point Victor had raised to me either earlier today or yesterday, but it sounds like we could capture a lot of the behavior if we instead just adopted the meaning that in any parameter as the last argument to a variadic function means unconstrained. Each type can be a different type. It's kind of like inconsistent. Whereas in any one, or one of these kind of bound ones, in the last argument could mean consistent. And I mean, that kind of feels like it jives well with the any one distinction as it exists now without introducing an additional parameter.
That's
Like any already, the unbounded, unenumerated any is kind of already the, like, you can have multiple of these in a function call. They don't have to be the same type, which is kind of exactly what we want for like JSON build objects and other things. Like for the endless example, I think that's a core expression, and then for like building arbitrary structs, we have core expressions for that as well to handle.
The magic any versus any one thing.
Yes.
That was not. I don't believe that was intentional. I think that may have come from me. That was not intentional. So it was not considered for this feature. I agree. I think I agree that it is. I'm not sure that's the same thing. I was going to say I think it is the same thing, but then I'm like, I'm not sure it is. It kind of feels like it's inverting the dynamics of types or something, like yeah, it's I mean, I see what you're arguing. I am not gonna yes, it kind of works. It just feels hacky. I guess that's what I would say. It feels like it's taking a hack and it's making it like, hey, let's use this hack in more places, in more different ways.
Do we actually have a documentation, like officially documents the difference between any and any suffix?
We do actually. I added that in. It's paying off a lot, which any one, let me find it.
It feels like, can we get rid of that? That's horrible.
Not just anyone.
I'll post this in the chat.
Yeah, any is a sentinel value, whereas anything else is not a sentinel value, or it's not a specific sentinel value. Yeah, I don't know what to say. Yeah, it's like, yeah, it's a weird.
Any implies no restrictions. Anyone implies anyone is really generic.
Do we only allow up to any 9, not any 0?
It's like Excel. It goes to any A1 and then any A2. No, just kidding. Sorry.
The regular expression only allows.
This actually has come up before. Like we allow arbitrary numbers of them, and it was also a real. If someone wants more than 10 any enumerated any's, they should come talk to us and be like, "What the hell are you doing?"
I mean, there you can see the examples of this .NET or the C++ allow up to like 10 or 32 periodic arguments. After that, like it's you're free for all.
The other point,
You get tired of writing function definitions after a while. I stopped at 4, but I could certainly see going a lot further.
You mean for your unnest implementation?
Yes.
Yeah.
but I guess yeah,
I mean,
the
30 is not unreasonable.
We had this experience. I'm going to go off topic here for a minute just to enjoy this, but we had this experience where the bit width of the hash table key, we were building compiling code for every, I don't know if it was every bit width or every byte width. I think it was maybe every byte width. Because like a 4 byte key versus a 7 byte key, there's a huge difference in what you can do. And so in terms of performance, it makes a huge performance impact. And we had to stop, I think we stopped at 128 variations of the hash table code because the compilation time and the binary size just got way too big. Yeah. Anyway, so I appreciate highly customized things. Yeah. So I have no strong opinion about this. I mean, I think that like going from something that is very explicit to something that is more implicit, which would be moving from the current pattern to an any one. I think there's two different questions, which is one is, do we think it's useful? And the second one is, should we change the representation? I think the question you're asking in the context of is it useful is, if we don't have any functions in the core, does that mean we should have it? And I think yes. I think the answer is yes. I think that like because when you actually get serious with this stuff, it becomes an important thing. Even though it's not the functions that anybody implements to start, right? Like if you think about it, and I think this maybe is partly about where you guys are working, right? Like you guys are the Datadog folks, I think, are largely working at the logical level, right? The kind of higher up in the tree, right? If so someone hand waving, okay. But like as you get into like the lower levels, right, that kind of thing becomes more useful. Where it's in the higher levels, you might just have, a tree which is, like it's just like, for example, like OR collapsing, right? When you have 17 OR statements, like initially maybe in your logical tree you have 17 separate OR statements, but when you get down to actually putting it on the CPU, you're trying to combine all those things together and execute them at once. And so this is not exactly that, but it's the same kind of pattern. And so I think as you get closer to actual like computation, this becomes the consistent becomes more important. I think that the inconsistent is more likely to be something that's going to be interacting at the much more higher logical level. So anyway, so I think it's useful. I don't think it's necessary for us to have functions in the core spec to keep it.
My caveat there is there's nothing in the core spec that uses it. We can't really document what it does. And part of the conversation here is that I'm asking like two of the original PMT members from like 3 years ago when this was added, like, what was this actually added for? And there's no clear answer to it that we're aware of. And it potentially is quite useful, but like, it doesn't spread joy. It's not super well documented. I still don't really fully understand.
I'm sorry, did you just say it doesn't spread joy?
It doesn't spread joy. Sorry, I'm Marie Kondoing the spec. Something some of the Ben is holding me accountable for is that like, as we add new features, I think we should be better about documenting them to be like, here's how you would use this and what it is for. And as we start looking at older features, we start running into why we want to do that, to be like, here's something in the dialect that we've been using. It doesn't seem to actually be commonly defined in where there's no default value for it declared anywhere. Not sure what the usage of it is. And if we don't understand how people are using it, how can we ever hope to specify it in a way that's coherent for people looking at it? And my inclination is
we just gave examples, right? Like those are all real examples.
Those are not real examples. There, a
Boolean OR amongst several different, like a binary OR amongst several values
that are not like numeric,
or binary AND amongst several values. Those are real.
Binary and like
the intersection of like the bit intersection of 25, 64 bit
at that point it's like a variadic function, binary and any, because like if you use any one, technically the way that I can interpret that is if you use any one to say I want all these to be the same type but they're inconsistent.
But I'm saying you're coming up with there's two different things, which is like, let's focus on the two things, keep the things separate. One is the ability to express consistent versus inconsistent value, right? That's one question. There's a separate question, which is what's the way we should represent that? And so the first case, which is I want real examples to show that it's valuable, right? I feel like the binary OR and the JSON build object or whatever it's called are examples of why inconsistent and consistent are useful. I think those are real examples. I don't think they're pretend examples. Do you agree with that or disagree with that?
I don't disagree with that.
Well, that's a step towards agreement. So the separate question, which is, hey, why don't we use a different representation than what's currently in the spec? Or like we seem to have two different ways to represent this. Now, I think I'm probably in the same spot when you say using any one versus any in a variadic position is meaningfully different. I don't believe we've got that defined anywhere. I don't agree with that. Right? Because we don't have any place where we've defined that a wildcard variadic is the same as expressing them like discretely. So we could define that, but I feel like that's like, it's like, hey, like that's another way we could define how bariatric works, which is, hey, there's this special behavior, which is that any versus anyone has this, what I would call an expansion behavior that is defined in this way when it's in a bariatric position. So yeah, so I feel like we should keep those things separately. So I like, if we believe that it's useful and we believe that we have real examples, that's good, right? And then there's a separate conversation.
Is binary OR the same as bitwise OR in this context?
Yeah.
Okay. Because the other thing is, I'm looking at it, it's like, wait, I thought we had this operation, and we do, and right now we don't use premises because we only allow bitwise OR between the same types.
Yeah, but we only have it for 2 operands.
Yeah, we don't have a bariatric version of it. No.
Yes. Yeah.
Mhm.
Yes. Yeah. So this example is the bariatric version.
Okay. So yeah, if we had a bariatric version of it, that would be an opportunity to be like, okay, let's add a version of it and then document how this works. Then.
Yeah, I was just proposing any one thing. To be honest, I don't really care about which one is the representation we choose. I think for me, the more important point is having examples in the YAML files, which sufficiently show off all the features of the spec, just serve as a really good way of testing the implementations to make sure that they're actually doing what we think they're doing. And the reason why this came up in the first place was because since it wasn't actually in any of the YAML files, it was never implemented in any of Substrate Java, Substrate Go, and then it started posing issues when people actually did start using it. So it's purely just a practical thing from my perspective, but it's nice to have these in there because then the tests fail, or things fail to be parsed, and then it's like, oh, implement this feature.
And we can also
Yeah,
point
but I think
support for it to be like, here's what this is supposed to mean. I think we ran this in Substrate Go where we implemented one possible meaning of the word consistency there, and it turned out to be we realized that like 305 meant 3 different things.
Yeah. No, I agree with that, but I think that the one thing that I would say that is I probably feel differently about than what it sounds like how Victor feels about this. Maybe I'm misinterpreting what Victor is saying, but I think it is fine to have examples to have demo examples in our core code base.
I'm on board for that.
It doesn't have to be things that people are going to use. Like I used that unknown type as an example of that, right? I believe we have the unknown type in there, right? I don't think anybody's using unknown type. Maybe someone is, but I don't think so. It's just an example to show how it works, and so I think that's fine for features.
100%. I'm on board for it. This doesn't need to be part of the core spec. I want an example. If it's part of the core spec, that's ideal because we can say, hey, we added it, and you can see exactly how it's used in practice. Or if it's just a theoretical example, because we've added a lot of features Ben has added a lot of work, has done a lot of work around having an example directory where you can add examples for specific things, and that would also work for me. I'm not picky either way. It's more because we don't have any. We have too many of actually. Because we don't have an example, it's hard to talk about this. And yeah, if we have an example of what this is used for, actually in some ways, Ben, if we have the example of the like binary OR, that would be a good conversation starter in the PR to be like, okay, how do we actually want to model this? Because the way I'm thinking about this is, I want the spec to do less, and if there's things that we're not sure people are actually using, get rid of them. And then if they come yell at us, it's like, you actually were using it. Please tell us how you were using it to make sure that we're on the same page.
I just wanted to say that I think I slightly disagree with what you're saying. Examples in the spec are good, and the current state of the PR has examples in the spec. But because they're like examples that live in this example directory, they don't satisfy the problem I'm talking about, which is Substrate Go doesn't try to load in those random YAML files from the site examples directory. So we wouldn't identify that this is a missing feature. Also, this feature does exist in Substrate Go now, but before it existed, we wouldn't have identified it. To me, that is my concern, because I want to make sure the implementers are actually implementing the features the spec says.
So I feel like that's the thing that I'm saying that's maybe slightly different than Victor, which is that he's like, I'm like the core spec to me, like that, I feel like that's kind of a loaded word. I'm like, I don't know what that means. I'm like, if an extension YAML is inside the core Substrate repositories, that means a core spec. Like, because I'm saying like add another directory inside of the extensions directory, that's called examples, simplified examples. And inside that directory, we can put things that we think people are generally not going to use, but are serve as reference points for people and also for implementations.
Or examples, or if you just a little like two-step like forward looking, we may define some compliance test. I think we briefly talked about the feature things, feature matrix thing, supported features. Maybe we could put those things under that, say, line of extensions. So compliance, and then you have these things, and then we can use it for the compliance test package. And
there's nothing stopping us from running the examples as tests in the language libraries. And I think the reason also bends on this is that we want to get better about putting examples of things as we add features. And yes, exactly for this kind of thing to be like, cool, you've added a feature, you've added a thing that checks the feature works. Let's wire it into whatever it is we're using to check all the libraries, and then you can get more data on the ecosystem.
Yeah.
Why don't we move the discussion to the PR? Ben, I didn't realize, I think I picked up your comment on we should delete this, and then I didn't realize you actually had examples of how you would use this. Why don't we continue the discussion on that PR?
That's good.
Yeah.
Thanks.
No, thanks for adding examples. Cool. We also have a couple small PRs that we've opened that we think are useful for people to look at. We're just gonna brief run through. We added lambdas, but we forgot to add a func short name, which we need to reference it to the spec. We should probably do that. Not a super interesting PR, pretty boring. We're clarifying the usage of ubang for UDTs, where for user-defined types, we haven't said anywhere that you're allowed to do bare references to user-defined types about the ubang. So Ben made a PR to just kind of make that language consistent and either require it everywhere. Well, we're requiring it everywhere in what he's proposing, but we can loosen it. But we should have a policy on it. And then finally, there's another small PR, and like, let's add a metadata object to the extensions to let people add custom metadata for things in various points. Yeah, those are not particularly complicated. But actually a good conversations on them, but not super in-depth. But yeah, just wanted to highlight those. But then David, Substrate Postgres.
Yeah, I've been working on a Postgres extension to pull in Substrate. I had something that was sort of working at the physical level, and discovered that the plans that Isthmus were generating were like cross joins and then filter later. And of course, those things, when you have multiple cross join levels, like you might have in TPCH, they never finished. So that led me to think about switching to instead of putting things, because when I had it implemented, I had to fix in the physical plan exactly as is, no optimization. And then it's like, well, if I take it in at the logical level, then I get the optimization, and of course, then you get a penalty, a performance penalty. So I was wondering if anybody had any thoughts of which is more valuable.
both.
You're going Substrate into Postgres, right?
Yes.
I would.
Not are you working on the opposite?
I have not started on the opposite. I figure the opposite seems possible.
No. Just think about it. I mean, my inclination. I don't think anybody's going to replace DuckDB execution with Postgres execution. And so my thinking is logical makes more sense to physical. Physical makes more sense if you're trying to use it as a performance replacement. I feel like Velox makes more sense at the physical level to me. But I feel like Postgres makes more sense at the logical level, because then you get things like index planning and whatnot. Like if you try to do it at the physical level, how are you going to express the use of a Postgres index in Substrate? We don't have
at the logical level makes it more accessible, I think, because then you don't have to have another thing to pre-optimize your Substrate plan, which is nice.
Okay.
I mean, eventually maybe we'll do both. We could have both, but I think if I was going to pick one, that would be logical.
As Jack said, I think both have values, but my value to Substrate is always logical. It's just yeah.
Like not Postgres for us, but even when we're using data fusion, we're doing a pre-planning pass in CalCit, which does all the fun like query join reordering and all the mega push down. But we still do a small amount of planning in data fusion to be like, hey, there are optimizations that you know how to do and like query access stuff that you know how to do. You can still do it, and it adds a bit of a penalty in planning, but
Yeah, I mean,
think
DuckDB does that to some extent too. I mean, they try to turn the optimization off, but they still do things like flat or muck with subqueries, for instance.
And I'm not sure about Postgres internals and physical, but I definitely found that there's a lot fewer assumptions in when you're making a logical plan than a physical plan, where sometimes that transformation bakes in certain expectations into the physical plans that aren't. You would have to recreate if you're doing it from Substrate without realizing.
All right, thanks.
Neat. So when can we expect this to get shipped to production, David? 2 weeks, 3 weeks?
I've been
Well,
working
Victor
on
wants
this
to use
for
it.
months.
Hey man,
It is
Claude Code or something, right?
It
I'll
is
fix it for you.
not easy for Claude Code to deal with Substrate plans because of the recursion. And it's even more messy when you're trying to actually figure out how to implement another recursive structure and appropriately get all the values. Most of the times it's crashing during execution because the values aren't properly constructed.
I'm going to put something out there. I was just thinking about that conversation we just had about Postgres. And the question that was in my head was, should we lean into the logical? Like when we started the project, it was kind of very much like we don't have a separation between logical and physical, in part because, I mean, the way I think about it is this is just like a large set of gradations, right? Like most things go through like 7 layers of like of optimization, moving more and more physical over time. And so like I haven't worked on a system myself where there is a single line that separates logical and physical. Like there's a really clear line that's okay. This is the side that's logical and this is the side the physical. I don't know, Young Chul, is that different for you?
I am actually living in both worlds. I mean, lived in both worlds. Now I'm back to where logical and physical are clearly separated. But even before my prior life, there was fair amount of distinction between logical and physical. Even though for the simplicity sake, we try to keep these things like, if possible, keep like they are same, but there are distinctions. And when the distinction exists, we try to be very, very clear about it. So, and because I said in David's Postgres thing, I always value the logical because I see Substrate is truly just as a basically protocol for the remoting operations. So I know you're able to doing this. So just I'll give you this expression, just run it for me. You do whatever optimization you can do, just run it for me. From that perspective, to me, it is very important to express the logical intent in very concise way. That's why I'm coming up with this all the fetch, and now it's closed because of inactivity.
We have a non-consistent
Really?
culture of.
Oh no.
No, I'm going to reopen it.
It can be reopened though. It can be reopened, It's working as intended.
Yeah. Yes.
A kick in the butt.
Yes, I can confirm that it worked.
Internally, we have a very clear and not confusing nomenclature of our planning system takes in logical substrate and outputs physical substrate, but in both cases, it's using the core logical substrate types. It's been optimized and reused. And if you use the core types, data fusion knows what they are. Versus if we have, I don't know if we ever had like custom physical nodes for everything. I think we had some in some cases, and we worked to get rid of them. We just made everything harder.
So
like the more standard stuff you use, the easier it is to interrupt. And sometimes you might really want a very specific thing, but we haven't run into that yet.
Yes. So in that regard, so I think it's important to concisely represent the logical stuff. So what you really want to do. that expressing that intent is important, but there's also value to express physical plan because, I mean, in the end, like you may generate like some partially implemented substrate because, yeah, I know this join can be useful for the hash join, but I really don't know about like how like indexings and or the vectorize. I don't know about the support. So okay, I'll give this like half implemented substrate back to you. You do the rest of the stuff. So so that's how I see the substrate in general. So yeah, that's my take.
And the distinction there
Yeah,
might be
no,
more as we start to target dumber systems. I think we're both like we're talking about targeting Postgres and data fusion, and we're talking about targeting Trino. We're like we're using Substrait to communicate plans, but all of these things already have planners baked in that can do like the what kind of join do you want to do? I think the question starts to become more interesting when it's like I have a dumb as a rock thing that's like I need you to tell me, do you want a hash join, an inner join, like a probe join, a dot point? That's when it's like, oh, okay. That's when you really have to be in the physical. But at least for us, most things we're targeting has some amount of brains.
Mm-hmm.
Is any? I'm just curious. As a very simple question, is anybody here using hash join right now?
We do.
Substrate hash join.
We do.
You do? Oh, okay. Interesting.
Yeah, I mean, that's just because we are, I mean, a way to passing around the hash join hint. So instead of like hash join hint, shove it into some extension. We just okay, let's just make it extension.
Yeah. Well, that's the weird part about hints, right? Is if they're often physical-ish.
Yeah.
Right. Even though they're at the
Exactly.
logical
I
level.
mean, hint
So,
is that's physical. Yes. Yeah.
all right. Yeah. It was just one of those things where as I think about it is I'm like, it may be the more we're clear about how we talk about this, the easier it is for others to understand how we fit and where we should be used.
Mhm.
Right. And if it's like, like if there's a spectrum, right, and like, logical's at this end and physical's at this end, and we say, hey, we're mostly focused on, like on this side, like it doesn't mean we don't like because what happens, and I remember getting this especially early on, is that people would reject Substrate because they're like, well, it can't possibly be customized enough to actually be used at the physical layer, so it's not useful. I remember hearing that a bunch early on. And then you're like, well, even if I can cover 70% of that spectrum, and I leave the last 30%, right? We leave the last 30% for internal system, all sorts of customization, whatever. As long as we have hooks for it, they can use our stuff. But we're not trying to get that stuff into the spec, right? Everybody's different cost models. We're not trying to get those in the spec.
No, we shouldn't.
And so I was just trying to think about, is there ways that we can do a better job of expressing where we're focused and where we're not? It might help others to understand where it would be useful.
Yeah.
Right. Because David just asked that question, right? And so David's in the core group, right? And he's asking that question. And so I'm like, well, like maybe our guidance should be is always start at the logical level. When you're working with Substrate, start at the logical level. And then if you get really advanced, you may start doing physical things. But generally speaking, start at the logical level. I think that might be a reasonable advice. I think that's probably what I think. I just don't know that I've ever said that. I don't know what others think.
And you have to think about it in terms of like the users that we might have, in terms of who's going to care about being able to talk to things logically versus physically. Where like logically is like, there's a data source I wasn't able to access before. Now I know it consumes logical substrate. I can now send it this new data system, these plans, and run them. And it's like, cool, I can now access new sorts of data. Versus the like, no, I don't want to just send you a logical plan. I want to plan exactly what you're going to do, kind of database sicko, which is like a much more specific use case. Does that make sense? Like, I feel like most people are like, the value is, oh, I can now talk to this thing at all, versus I can now talk to you in an incredibly specific way, which is still valuable, but like another level of like integration where like in one case, it's like, I just have to know about algebra. And the other case is like, at least for us in CalSci, part of it is like, we do query planning stuff for Postgres and data fusion. It's like, we have to know more about other internals to the point where it leaks into planning sometimes and it's not fun. And most people don't care. Physical feels like the enemy of a general whole. Yeah, it does.
Well, to be frankly, we haven't got to cover the complete logical things. if you start to dealing with all these like quirk optimizations for every systems doing their own like
Actually, it might be accurate to say as well that it's not that we're not interested in modeling physical relations, but we have to pick between finishing all of logical and then adding partial physical. Like if I was going to pick one or the other, I would prioritize logical. Like
yes, yeah, we should
getting window function, like getting group support types for window, getting group supporting for window functions, like proper range stuff for like non-numeric bounds.
Right.
Mesh recognize and I stare into the distance and cry.
Being
go ahead.
Being a exchange format, I think we need to really focus on distilling what is the conceptual model, or the abstractions. So yeah, you're doing a bunch of like let's say you have a hash join, so you may have like a lot of like variants or the variant implementation. Variant implementations, like let's say 128 different hash join implementation in your system. In Substrate, like we are never going to have hash join covering like all these like 128 variants. We will just trying to distill what is the hash join like abstract. I mean, try our best to capture the gist of the hash join operations, and then okay, this is the hash join you need to. So at that level, I think we can do. Certain operations, I'm hopeful we can distill those fundamental stuff, but I don't think we should strive for capturing like every single detail of the systems and so on. Yeah,
I feel like there's a lot of meat on the bones left of logical, and we can finish all that easier logical work. And then if that's wildly successful, it's like, cool, that's gone really well. Let's go eat the bones of physical and deal with that. Like,
I think that's the
do the easy thing that gives us a lot of value. I like to do the easy thing. Then it can be someone else's problem to deal with physical, like 4 years down the line when you have like 100 people in the community.
And honestly, if you go down that path, the physical can be always using extensions to just unblock, and that's what we are planning to do.
And that's kind of it has been the point of extensions, to be like, if you really want something very specific to your system, make it easy to add it. It reduces interoperability, but in most cases, if you're reaching for it, it's because you have a very specific use case that you're not going to be sharing anyways.
I just approached yesterday another team at Microsoft that trying to adopt this Substrate. So, and that system also is it's actually my old team. They are trying to adopt Substrate, so that's a good news. I'm sure they have like a lot of interesting story, quirk. so I'll share some of the stuff to the community.
And not to get too much into our stuff as well, but like we're currently using Substrate to target like relational query APIs to Substrate. That's pretty boring, but also like weird time series stuff into Substrate, and then also like schema on read Elasticsearch stuff into Substrate. So we're having a lot of fun mapping different things. But sometimes where our requests seem kind of weird, we're not really looking at SQL that much, except for Motion. You look at SQL all the time, unfortunately. But he's the one who complains to me when he can't translate something correctly because it doesn't exist, or it's not clear enough to know what it means correctly. But
I see.
Cool. I think that's it for like formal agenda, unless anyone has any other items. I think actually one quick note I wanted to add. Weston and I are working on getting an official Substrate organization for PyPy. We're going through the mechanism. We have Substrate emails now, which we can use to tell the PyPy people that we belong to Substrate. So can you please give us the Substrate org on PyPy so that we can publish our packages as an organization and not with, I want to say, Gil's random keys. But yeah, that's happening.
Yeah. I was like, am I already part of the Substrate organization on PyPy? I feel like maybe I am.
It doesn't exist yet. When I went looking, it didn't exist, so we're adding one.
It exists as of 5 minutes ago.
Oh, hell yeah.
Okay.
I will invite others.
Yeah, people invite me to these other like languages that I don't work in, like the repositories, and I'm just like, I don't know what I have. Yeah. think maybe part of the Rust, whatever the crate organization. Maybe I've got access to that.
This will come up more as I start to automate more of the packaging. I'm starting with Python because we have an internal use case that's blocked by it, and then move to Rust. And I think the IBM folks are interested in importing Java. So we'll just start to, maybe as we do that, we'll kind of get more official. We should have organizations for all of these that are like not tied to specific people.
Yeah, I'd certainly like to get text plan once it's in publishing to PyPy.
Yeah.
So Weston and Victor mentioned they have Substrate emails. Right now, the domain we're on, we can have up to 20. So if anybody wants one, let me know. I can add them. We could move to another system where we could have an unlimited number of them, but the current domain service that we have, it includes 20 with the registration. So if anybody else wants a Substrate email, just send me a email or a Slack that's exactly, it's up to 20. An email or a Slack that's like, hey, this is the Substrate name I want, handle I want, and I want to go to this email address.
Substrate dash any 1, 2, 3
Exactly. That's what no, you're just any2 at substrate.io. That's what you are. That's the 20 emails that we get. Any0 through any19.
Oh, any7.
Exactly. Yeah. So if you want to just email me or Slack me with your to and from names.
Any one stuff is funny because I feel like both Haskell and Scala, I feel like at their compiler internal somewhere have a file called like Scala or like tuple constructor, which has like 20 constructors for tuples up to 20 parameters. And it's like there's literally usually a note of like, if you need more than this, like don't. It's pretty common actually.
I think in Elm, maybe there's like a limit to the size of tuples. Like after 7, it's a compiler error or something like that.
That's awesome. All right, everybody. Well, have a good week. It's good seeing you all. Happy New Year.
Happy New Year.